Hello, Calculus 12 students. This week I have sent you Quiz 3 and Quiz 4. Quiz 3 and Quiz 4 are really like the study guide for the unit test for Unit 4 on applications of derivatives. In fact, I think pretty much every question that appears on the test appears on these quizzes, maybe in a slightly different form, slightly different question. Same type of question, just different numbers. Okay, so let's start off with going over Quiz 3. I'm going to call mine answer key. And we start off with a Newton's method question. So it says, recall the formula for using Newton's method to solve an equation. Okay, it's shown there. Use Newton's method to approximate all real solutions to the equation x squared minus 2x plus 1 equals sine x. Give your answers accurate to the number of decimal places that your calculator will show. There are two answers to find. To find the first one, start with your first guess as x0 equals 0.5 and continue from there, showing each iteration until the answer appears. To find the second one, start with your first guess as x0 equals 2 and continue from there, showing each iteration until the answer appears. Make certain your calculator excuse me, is in radians. Okay, so the equation that we really want to solve, guys, is this. We have to have our equation equal to 0. So I'm going to subtract sine x from both sides. And our equation is this, x squared minus 2x plus 1, minus sine x equals 0. Okay, and so as a function, it is f of x is equal to x squared minus 2x plus 1 minus sine x, and f prime of x will equal 2x minus 2 minus cos x. And remember the formula for Newton's method. And I'm going to plug in what we know so far. Xn plus 1 is equal to xn minus f of xn is going to be xn squared minus 2xn plus 1 minus sine of xn, all divided by the derivative 2xn minus 2 minus cos of xn. Okay. And we may want to put this whole thing in brackets as well, just to be safe. Okay, and so let's start off with the first one. x0 is equal to 0.5. So I have to plug 0.5 in for xn in the Newton's method formula. Okay, so notice it's xn, so 0.5 minus, then I'm going to kind of double up the brackets here a lot. Okay, so open bracket on the top, we've got to have xn squared, so 0.5 squared minus 2 times 0.5 plus 1 minus sine of 0.5. And before I go any further, I'm going to go mode, and yes, make sure I'm in radian mode. Now I'm in radians. Sine of 0.5, and I need to close the bracket on the top and then divided by, and I'm going to open a bracket on the bottom, 2 times xn minus 2 minus cos of 0.5 And I'm going to close the bracket on the bottom, and I'm going to close the main big brackets around the whole fraction. Okay, so x1 is now that. Okay, so x1 is equal to 0.3778080159, and now we can try to figure out x2 and so on. Oops. Make sure I wrote that down properly. Yes, that looks good. Okay, so then we go, in order to put the word answer into our x0 spot, you go second function enter. We want that entry word in yellow there. And when you do that, then you can go back and edit. So everywhere that I have put in a 0.5 for xn, I have to replace that with the word answer. So I'm going to go second function minus sign. And notice that it leaves off some residual there, like the point and the 5, like it just replaced the 0. So I have to delete the point and the 5. And I'm going to go second function answer in there. That's where I put a 0.5. I put a 0.5 here. Plus 1 needs to stay, and then a minus sign of xn, so we have to replace this with answer. Delete that 5, delete that 0. And on the bottom, it's 2 times xn. Replace that with answer. The minus 2 needs to stay, and then it's cos of xn, so we'll replace that with answer. Okay, and so then x2 is this. Zero point 386,198,1183. And let's make sure that's right. Enter again, 0.386,236,8698. Okay, and x4 now is going to be that. We're starting to get... Okay. Okay, 0.386,236,8706, and if I press enter again, hey, I get the same thing, and I get the same thing, so we found our answer. So x5 is the same as x4, so there's the solution for that one. Okay. Okay, we said there are 2 answers to find. To find the second one, start with your first guess as x0 equals 2. Okay, so for the x0 equals 2. So I'm going to start again, and I'm going to put 2 in for xn. So it's got to be 2 minus main brackets for the whole fraction, bracket for the top, and then I'm going to go 2 squared minus 2 times 2 plus 1 minus sine of 2. Close the bracket on the top, divided by 2 times 2 minus 2 minus cos of 2. Close the bracket on the bottom, close the bracket for the fractions, press enter. So there's x1, 1.962459,826. Now, second function, enter to get that, and edit. And remember, guys, we have to be careful here because we're not just replacing every 2 with answer. It's just the xn's that were replaced with 2, right? There are some 2's in the formula here that need to stay, right? Like if we look at the formula over here, that 2 needs to stay, and so does this one, and this -2 as well. So we got to be a little bit careful to make sure we're just replacing the x0's with the word answer. So the first 2 was in an x0 spot, so I'm going to replace that with answer. And then it was, yeah, xn squared or x0 squared, so I'll replace that with answer. And then it was 2 times xn, so just the second one is answer. Plus 1 needs to stay. Sine 2, that was sine xn or x0. So we'll replace that. On the bottom, it's 2 times xn, so that first 2 needs to stay, but the second one needs to be answer. The -2 needs to stay because that was a constant, and cos of xn, so that needs to become answer. So there's x2, 1.961. $569,538. Okay, press enter again. $1.961. 569,035. And if we press enter again, that is the same. So x4, the answers start to be the same. And you can see I press enter again and I get the same thing. And I get the same thing. Okay. So x3 is our answer. Okay, and that is how you do number 1 on Newton's method. Okay, let's try number 2 here. A spherical balloon. Ooh, sphere. Spherical balloon is inflated with helium at the rate of 50 pi cubic feet per minute. The volume of a sphere is given by V equals 4/3 pi r cubed, and the surface area of a sphere is given by surface area equals 4 pi r squared. How fast is the balloon's radius increasing? At the instant the radius is 2 feet. Give your final answer as an exact value in terms of pi if necessary. Okay, so let's do the find when given thing. How fast is the balloon's radius increasing? So we want to find the change in radius with respect to time when at the instant the radius is 2 feet, so when r equals 2 feet. Given, we'll go back up here to find our given information. A spherical balloon is inflated with helium at a rate of 50 pi cubic feet per minute. That is the change in volume with respect to time. Okay, so imagine this spherical balloon is what I'm trying to draw here. Okay. The volume of a sphere is 4/3 pi r cubed. Let's take the derivative of this with respect to time. So we would get dv dt is equal to 3 times 4/3 is 4 pi r squared dr dt. And we want to find dr dt, so we're going to have to divide both sides by 4 pi r squared. dr dt is equal to dv dt divided by 4 pi r squared. dv dt is 50 pi cubic feet per minute, and then 4 pi r squared, r is 2 feet. Okay, and so dr dt is going to equal I'm just going to leave, the pi's will cancel, right? So it'll be 50 divided by 2 squared is 4 times the other 4 is 16. So it'll be that, math, we can fraction that if you want. Could write it as 25/8. And that's going to be feet per minute, because you'll have feet cubed divided by feet squared. Okay, which is 3.125. All right, part B, how fast is the surface area increasing at that time? At that instant? Surface area of a sphere is 4 pi r squared. And actually, maybe we should do our find when given thing, right? Find. How fast is the surface area increasing? So we want the change in surface area with respect to time. When? So at that instant, so still at the instant that r is equal to 2 feet. And the only given thing we had still was the change in volume with respect to time, which I don't think is relevant in this question. Change in volume with respect to time is 50 pi cubic feet per minute. Okay, so the surface area of a sphere is 4 pi r squared. Change in surface area with respect to time is 2 times 4 pi is 8 pi, and then it would be r to the 1 times dr dt. Change in surface area with respect to time is equal to 8 pi times 2 feet for r, and the dr dt is what we figured out up above, right? So it is given that the change in radius with respect to time at that instant of r equals 2 feet is 25/8 feet per minute. Bang. Okay, so 8 divided by 8 cancels. We have 2 times 25, which is 50, times pi. So the change in surface area with respect to time is 50 pi feet squared per minute. All right, and finally, number 3. I'll do quiz 4 for you perhaps in a separate video. Okay, number 3 says, a trough is 14 feet long and 6 feet across the top as shown in the figure. Its ends are isosceles triangles with height 3 feet. The volume of the trough is given by the formula volume equals a half times the base times the height times the length, where L equals 14 feet is a constant. Water runs into the trough at the rate of 3 cubic feet per minute. How fast is the water level rising when it is 1 foot deep? Okay, and so I'm pretty sure on the test I actually have the diagram there for you. And this is what the diagram would look like. Okay, so imagine a trough like this. So the trough is 14 feet long, so we could put 14 here, and 6 feet across the top. Its ends are isosceles triangles with height 3 feet. So the height here is 3 feet. Okay, we have a formula for the volume. L equals 14 feet is constant. Okay, and so water runs into the trough. So imagine we're dumping water into this, and the water is going to start filling up like so. Takes the shape of the container, right? Okay, so there's our water. And so let's do our find when given. It wants to know how fast is the water level rising when it is 1 foot deep. So the water level is here, h. So they want us to find the change in height with respect to time when it is 1 foot deep. So when h is equal to 1 foot given okay, what do we know? Water runs into the trough at the rate of 3 cubic feet per minute. That is a change in volume with respect to time. Cubic feet per minute. Okay, And so now we need a formula involving h, the height of the water, and the volume. Okay, and so the volume of a rectangular prism is given by half times the base times the height times the length. Basically what it is, guys, is it's the area of the triangular base here, and then if you multiply sort of by the length, it'll give you the volume. Okay. And I just want to fix up a couple things here. That was 6 feet. This will be B. The L equals 14 feet is a constant. So notice like the length of the water here, guys, this will always be 14 feet as the water level rises. Okay, so as the water level rises, the height changes, h changes, and the base changes, okay, because it's a triangle, and so the base is getting wider as you go up, but that length of the water should remain at 14 feet. Okay, so the length of the water should stay as 14 feet. That's going to be constant. So now here's what we have. We've got a half times 14 feet times base times height. Okay, and we said that the base changes and the height changes, so that's no good. We have to get rid of either the b or the h, and we actually want to find dh dt, so we need to try to figure out b in terms of h. And I'm sure you probably guessed it, we're going to have to use similar triangles. Okay, because you notice we've got like the big blue triangle, which I've just butchered. The big blue triangle, which is 6 feet up here and 3 feet in height. And then we've got the little red water triangle, which is B and H, like that. Okay, and those are similar triangles. They have angles that are equal. Okay, which means base divided by height in the red triangle should equal base divided by height in the blue triangle. So B over H equals 2, so B equals 2H. And so now we can go and replace B with 2H. So I'm going to put 2H in here. So our volume formula is a half times 14 feet times 2H times H. 2 times a half is just 1. So we're going to have 14 feet times H squared, and I'm just going to knock off the feet here for now. I was just keeping it in there so that our units stay straight at the end, but it's becoming inconvenient. So I'm just going to get rid of it, and we'll try to remember the units at the end. Okay, so there's our formula involving volume and height. Differentiate both sides with respect to time. dV dt is equal to 28 times h, and then dh dt. And we want to find dh dt. So I'm going to divide both sides by 28h, and we will have dV dt divided by 28h. And the dV dt is 3 cubic feet per minute. Divided by 28 times, what's the h? At h equals 1 foot. Okay, and so here's where like the units will come back in. Okay, so we've got 28, but notice the 28 came from the 2 times 14, and the 14 was in feet. So the 28, that's in feet, and then it was times h, and that was at the instant h was 1 foot. So notice we have feet squared on the bottom. Now this is making sense. Our change in height with respect to time will be 3 over 28, and then it's cubic feet divided by feet squared, so we'll be left with feet per minute. Alright, so that's how you do number 3. I will do another video for quiz 4. Okay, so I will talk to you guys in a bit here.